Okay, welcome everyone, and thank you for coming for my presentation on blockchain. So my goal here is to demystify the development on the blockchain. I will not talk about why you need to use a blockchain. I'll let you look on the internet if you want to have arguments on that. So my name is Benjamin Fuentes. I'm coming from the city of Wines, Bordeaux. I worked several years in Luxembourg on Java technology for banks mainly. I'm based in Nice, that's in France, south of France, and I've been the last 2 years traveling around Europe for blockchain advocacy. I'm currently working on blockchain on the travel industry. So here is the summary. I will start with a short introduction on blockchain. Yeah, maybe better the mic here. Thank you. So I will start with an introduction on blockchain. Then I will talk about several implementation, but one in particular that is Hyperledger Fabric. And then I will finish with a demo implementing a smart contract for the airline industry. So about the introduction, I will talk about Bitcoin, Ethereum, but very fast, and I will stay a little bit more on Hyperledger. First, to start, what is a blockchain? So you can have several definitions. I took one, it is extracted from Wikipedia. What you have to think is something that is immutable, like this ledger that you have here, a very old ledger that is on a stone. So it's something that the trust here is because you cannot change what is written. This comes from, it's about distributed systems. So this works, I'll start with a paper from Leslie Lamport in 1982 named the Byzantine General Problem. He wanted to resolve what we call a global state around distributed systems. So here is a fictive story about commandants and lieutenants or generals. It's an army who wants to attack a city. And these guys, they are several parts of the armies, and they communicate each other only by messages. The thing is, sometimes you cannot trust or the general or some lieutenants in the army, but globally, what you want is to take a decision, even if you have traitors. So, main usage about blockchain that we know today is mainly the digital currencies like bitcoins, but you have now what we call smart contract or chain code. I'll talk a little bit of that later. So a blockchain is a network, a distributed network. So you can see there are several nodes, 3 nodes here, and they are communicating through messages. And the goal is to have everything synchronized on almost real time, not having a single port of failure, everything is replicated, and to be unstoppable. So if we zoom a little bit on one particular peer or node in the network, is here what we find in every blockchain. We have this chain of blocks. So all the time we start with the genesis block here, and we have one hash that is the hash or the payload from the payload. The hash is hash of the payload, and you have a link to the previous hash in the chain. So you are chaining the block like this. If you are modifying some block at one moment, you have to recalculate a new hash for the new block. Okay, that's why it's good against tampering. For adding a new block, what you need is a consensus system. This interesting question that we have here is CIP theorem resolved by the blockchain. It's still an open question, and I let you think about at the end of this session. For the one that doesn't know what is a CAP theorem, here you have a resume. So keep in mind this question, and I'll let you think about it for the end of the session. So Bitcoin. Bitcoin is the first implementation of the blockchain. Bitcoin is not, I would say, the implementation of blockchain. It's more the application on this technology, on a particular case, that is exchanging digital currency without the need on any intermediary and with no censorship. So it comes from 2008, and this has generalized what is a blockchain in general. Something about Bitcoin is based on a consensus that is named proof of work, that is quite heavy in resource. In fact, it's taking a lot of energy to consuming a lot of energy. Another implementation of blockchain is Ethereum. It comes from a fork. It's a fork of Bitcoin in 2015. The goal is not the same. They are more like a code cooperative platform, I would say. In fact, what we have here is a network of computer, and if you want to deploy a smart contract or an application on it, you have to consume tokens they have on the networks. There are some units that you need to buy to execute your application on the network. So they introduce what we call today the smart contracts. In fact, you have one smart contract in Bitcoin. It's the smart contract that is dealing with the exchange of currency between two users. But you cannot change that. What about Hyperledger? Hyperledger is an open source project under Linux Foundation, more than 100 members. And the goal is to bring all the bricks that you need to build your own blockchain. It's mainly focused on the business side. Bitcoin is more for anyone, I would say. Hyperledger is for the business. You have different implementation in Hyperledger. You have Fabric, that is mainly supported by IBM, DTCC, and DHA. You have SourceTools Lake, that is one implementation by Intel. Iroha, that is maintained by Japanese companies, and you have sub-project here. They are coming and still in incubation. If you see one particular one that is Fabric, here are the key features. You don't need any token. It means that you don't have to buy any digital currency or whatever. That's a good point. It's based on pluggable consensus that you can change the way that the consensus works. But the base is BFT consensus. What you want BFT, Byzantine Fault Tolerance consensus, and one is coming is based on the consensus that is in Kafka. You have channels. They are used here to separate and to have more privacy on the blockchain. You have endorsement policies for transaction. It means that there are rules or who can call this particular method on this application. You have different way of storing your state. I will talk about that later. So you can store like in a database in a key value storage or in a JSON style storage. You have the membership service provider, that is the authority that's giving the certificates. You can have any client that you want because it's based on protofiles. It's based also on Docker images, that is easy to start. And smart contracts can be written today in Go and in Java. So the basics. So here are the actors that are involved in the blockchain project. You have the blockchain user that in fact is an application user, is a Lambda user that you are used to. So you can use an application that doesn't know behind that is a blockchain or not. You have the blockchain developer. He's responsible for two things. Writing the smart contract. So this is the application that is embedded inside of a peer, and also writing the client application who are dealing with the smart contracts. The regulator with all the auditors. The certificate authority is very important. Bitcoin and Ethereum, they don't have especially certificate authority because they want everyone to enter in the network. But the business is different. In the business, legally you cannot, if you have a problem, you need to know with who you are dealing. That's why we call that a permission blockchain or private blockchain, but I don't like this word. So it means that you need a certificate authority that just give you a token. It's more than a token, it's private keys for signing transaction, encrypting transaction too. And you have our external system around that. They are communicating with your application. If I decompose in which components the bricks of the blockchain. So here you have the ledger. So there are two parts in the ledger, in the Hyperledger Fabric. One part here is a symbol of a database. So is the state is really a database behind. It depends on the implementation that you want, the keybase, or you can use JSON storage like Cloudant. This is storing the real state of the system. So you can query the real state in the system. And the other part here is what we see in the other implementation of blockchain is the chain of blocks. You can see that like immutable logs who are linked together by cryptography. The other part is a smart contract. So this is your application, the logic code that is embedded in your peer. You have a consensus mechanism. So in Hyperledger you can plug different ones like you will see. You have the membership services. That is the one that is responsible for managing the identities and the transaction certificates. So here you have two different kind of certificates in Fabric. One they are called entitlement, and one they are called transaction. This one, it means that if you sign a transaction with this unique one, anyone can know who was signing this transaction. But you can derivate other certificates from the primary one, and these are totally anonymous to the others. So you can have like herbs, anonymity. You have events. So events, they are like a notification, they are raised after a smart contract is executed. So everything is asynchronous. So you cannot do when you are querying, in fact, the smart contracts, you will send you first an answer that everything is okay because technically your call is okay, but the real answer will come back after in another event that really certified that everything has been synchronized after the consensus has passed. You have all the tooling that is around for monitoring. You have the wallet. So it's not a coin wallet. It's a wallet that is containing all your certificates and your credentials. And our external system, they are dealing with your application. So what are the interaction you can do with your application? So you have a SDK. So in the V1, we are talking about the V1 of the product. In the V1, you can use only a SDK where you have your wallet on it, no more HTTP. So you have to use the SDK to do the enrollment, to get your certificates first on the membership services, and then you can interact with any peer on the network. Here are the main functions or methods that you can use. Installing, copy your application on a peer, it's just a copy. Then when it's copied, it has to be instantiated. It means that it has to run inside your peer. What after you can do is querying your application is just query, a pull, whatever. And invoking. Invoking will change the state of your asset you are managing inside of your application. That is important because querying doesn't create any block, but invoking will always create a new block on the log and will change the state of your system in all the network. And the last one is a new one is upgrade. It means that you can have a new release of your application and plus one version on the network. It's like a sequence flow. So first, you need to deploy the smart contract. You need to write it and then to deploy it here. So you have the blockchain developer, then deploy the smart contract, and then in the client application, and then a user will use it through the application. The SDK, it will query or invoke methods here that could or get, this is a get, or a change here, put state will change the word state, and then the response, or we come back directly if it's a get, or you have to wait if it's an invoke for all the system to be synchronized and to retrieve this event or this notification, waiting for it. Okay, developing blockchain application, they are not very the same that developing any application, because here you are in a distributed environment. So it means there's two kind of problem you have to face. This one, it's a get or a pull. So it means that the user has invoked one method here is to get information from the smart contract. So it means in any peer, it will be executed, and they want to retrieve an information from the same external system. So here, for example, I want to get a timestamp from an external system, so I will have 3 calls here, but I will get maybe different timestamps. So it's really a big problem, because here maybe my timestamp is part of formula or whatever, so I will have different results here, and the system will never synchronize again. The other way, it's a put. So you are changing here the data from your smart contracts who are running on the network. It means here, for example, I have a bank account that is an external system outside of the network, the blockchain network, and I want to put €1 only on my bank account. Here, the result is I can have +3, because each one will do +1 on my bank account. It's not what I want. So there are several techniques to avoid these kind of problems, using proxies in the middle. Okay, going a little bit deeper. So what you have seen is this client application here with the SDK and the wallet, the membership services, and the peer. You have another thing that is a special peer that is called an orderer. So the role of this orderer is to order the transaction they are receiving for all the network, because everything is worldwide, is totally distributed, and you need one system or a pool of orderer, it could be, that make just ordering the transaction. So you can see the consensus mode, or you have one that is single node for the solo is a single node for development that we use. Kafka is coming soon, is using the consensus in Zookeeper. Before we have PBFT in the V06, is coming as PBFT in the future that will replace PBFT. So no more HTTP API using the SDK now. The SDK use gRPC, so the protocol are using this RPC protocol from Google. And you can have today SDK for Java, Node.js, and Python. This is for the client side. A runtime service provider is based now on Cloudflare Toolkit that is open source, still use ECDSA, elliptical digital signatures algorithm like Bitcoin, the same. Here is what I told you is two kind of way to store your data. So now you have the choice before you have only one key store, key value store that today is LevelDB, it has been reviewed by LevelDB, and here you have a JSON store that is CouchDB that I will use just after. Very important thing that is unique for an implementation of blockchain is the ability to upgrade your blockchain. That's quite important because you have to think that your code that you are deploying, you cannot change it because it's part of a block, and the block is immutable. So how you upgrade an application if you cannot change the code? That's a big problem. So it has been solved here by Hyperledger Fabric using like a redirection and keeping your database, your state, and you can deploy a new version of your application. This is quite difficult to do with Ethereum. They don't have this state. They copy everything in the same block, even the state. Another feature that have been asked is the ability to query an asset. An asset is just data you just store in your database, but in the past. It means that I would like to know in my n-3 block what was the state of my asset in my database. It's a little bit like Hibernate inverse, the one who knows that. So we have been asked and it still functions. Okay, let's do for demo. How long I have for the time? It's okay. How long I have for the time? 5 minutes? 20 minutes? Oh, great. That's left. 10, okay. 12. 30. 30.
Half an hour.
Oh, great. Perfect, perfect. Do we see what here? Okay. You see? Oh, yeah. So my use case, very tiny use case I took for blockchain use is on the airline industry. Here is the flight insurance. So maybe you have experienced this kind of problem that you arrive at the airport and your flight is delayed. So there's some insurance that prevent this kind of problem. So you can say that you want to insure your trip when the flight is delayed by X minutes, you want to receive some money. It's an insurance. So you have this kind of, it's truncated here. You have this kind of rules or contracts that you can say. It means that you have here the delay in minutes and how much you want to be redeemed. And some companies, they are even doing some estimation that percentage of chance that you are going to be redeemed. That's funny. So what I will do now is, okay. It's not easy with the mic. Whoop. I don't see very well. No. Okay, we don't see very well. No. Okay. Okay. So I'm using here a test environment. It means that I don't have a lot of nodes up here to run. I will use this, the one that for development. It means that everything will be in one simulated node on my computer. But a real network is not everywhere in the world. You see more or less. Okay, so I'm using the core compose to run a network here. So okay, okay, I have one peer, one other, a client Docker container. I think everything is fine. Okay, so I'm opening another one. So now I will connect to one Docker container for starting my application. So my application is flight insurance. Go to the directory. I will build my code. It is Go-based smart contract. I will show you everything after. Just want to show you what is for the demo. So I'm building my code. Okay, fine. And then I will run. Okay, started. It's ready. Now I have prepared that. What I would do now is I would try to, I will use the client, but not the SDK. I will use directly command line client. Will be faster. So I'm opening another one. Okay. Now I use the client now to say that I want to copy the chain code, so my application is registered. Okay, now I will have to run. I use instantiate now. So now it's running and registering my smart contracts in my client. It means that it has getting back my certificates, everything. I'm ready now to query and to interact with my smart contract. So let's start a little bit here. So here what I will do now is I will create a contract, but not a smart contract. It's an insurance contract. So this is an object, okay, a business object. So I will create this this contract for. So I will invoke this method that I have in my application, and I will pass some parameters. It means that I will create a contract for myself with this company in this flight for this departure hour. And my contract says that after 2 minutes of delay, I will be redeemed of €4. That's all what it means. Okay. So now this insurance contract is, for me, it's an asset. So in fact, I'm registering this in the database if you want. So it says here, chain code invoked successfully. So he has registered this object on the database. So I know that here the ID is this. So I will keep this ID in a place here. Well, because I want to query that after. This is the next command. I will query my application to know if the contract is here in the database. Let's see if everything is okay. Okay, answer me my query. So my object is store. So here is in one node, but you have to imagine that if you have a full network of 100 nodes, this action has been done 100 times in all the network at the same time. So I'm querying here the same node, but if I query another node where I haven't put the first command, it will answer me exactly the same question because locally the state is exactly the same. So everything is fine. I will continue and I will create another contract. So another, not smart contract, but an insurance contract for another user that is named Juana, that is taking the same flight. do that. Okay, so now I have two objects in my distributed database, if you want, my network. So what is the next step? I have this contract, this insurance contract there already. Now I need for the plane to take out, okay? Take off. So I will send a command here on my application that is, the method is named update flight insurance on flight delay. It means that the take is taking off, and I will give him in parameter which flight, what is normally the hour of departure, and what is actually the hour this is as takeoff. So here you can see a difference of 10 minutes. It means that the delay has been really 10 minutes. So here I'm doing everything on my computer, but you have to think about this should be an oracle somewhere that is tracking the plane and is doing the difference when the real departure and the expected departure. So it can be tracked by IoT stuff, or an oracle or another blockchain can store this information. You know, you need a trustable oracle to give you the information and to launch this function. So I will do it manually. I will take off the plane. Okay. So if I come back to the other, I have the logs of my smart contracts. Here I'm looking on the peer, and you can see here on the logs. You see what? Yeah. All the parameters. Okay. Let's move the logs. So there are effectively two contracts that have been executed. Insurance contract. One for the passenger named Benjamin and the other passenger named Juana. You can see here on the logs, it's truncated more or less. Okay, I don't know why. That for the passenger Juana, nothing happened. But for the passenger Benjamin, because he put 2 minutes and Juana had a contract of half an hour. 10 minutes in between the two, so only Benjamin will receive something and they redeem of $4. So now have a look on the code. So the code is, how many people here are using Go? Woo! Sorry. It will not be too hard to read, really. So here is my data structure smart contract. Here I have another one. This is my object I'm storing on my database. Okay, it's quite obvious. So when I'm creating a contract, I'm creating this kind of object and I'm storing this object. Here I have some statuses. Here I have the main function. It's just starting, in fact, the application. Nothing to see here. Here is a neat function that could be useful, but not in my case. Is every time you deploy the smart contract, you can invoke an initialization function if you need to do something at the beginning of your application. Well, I have nothing to do here. Here I have the entry point. Thank you. Yeah, the entry point of my application is the invocation function. So it's like it works like a dispatcher. When I'm using the client, I will use query or invoke. But here inside of your chain code, this has been changed. The first parameter here is the name of your function, and the other, they are the arguments. So you need this dispatcher at the beginning. When you are invoking a function, you need to pass first the name of the function and the arguments. So what I have done before, I have invoked create flight insurance. This is to create my insurance. So it's not doing a lot of things. It's just receiving the object that you have receiving parameters and is storing this object inside of the state. Step 1, put state. Just doing that. This is to create an insurance contract. What I have done after is I have a query. So I want to retrieve this contract inside of the database. So I invoke this function after. So this is also quite obvious. It's just taking a few parameters to retrieve which kind of insurance I have. So I think I have not a lot of arguments. It should be the ID. Links args. So I'm taking just the ID of the insurance object. And then I'm calling the function. I'm not sure where is it. Get state here. So get state is like find if you want. So it's getting the object from the database, is returning back here to the caller. Nothing special. And the last one is when I ask my flight to take off. So in arguments, you have the flight number, departure date. These are the compose key if you want to retrieve my flight. And then you have the real departure date that is given by the oracle, not the real date of departure. So what you need to do here, you need to retrieve the flight in the database. In fact, you need not to retrieve the flight, when register the flight. You need to retrieve all the objects, the contracts, they are pointing to this flight. So I know I have two. So you need to have a loop. And in the query, you have, because I am using a JSON database, this is CoachDB, you need to have like the where condition if you want. This is a selector, it's the same, but the where condition in SQL. So I'm passing the arguments, and then I have a for loop here. And what I will test here is for each one. Where is the condition? I will change some statuses and everything, and I will test the delay here. So the one that's been stored with the contract in the database, and what is the real difference in the reality. So here is a test, and if I need to do something because the delay has been passed, you have several choices. Or you are doing everything inside of the blockchain and you have like an account that you can add some digital money inside of the blockchain, or you can call an external system to redeem the user. It's up to you. And in the case, you don't do anything, and after you change the state of your contract to say that it's finished. Otherwise, an oracle can invoke again, and if you don't manage the state, you can be receiving several times a redemption. That's not good. And that's it. It's quite simple. Do you have any question? I think I'm done for the technical part. Yeah. So if you have any question or any ideas about project or anything, you can contact me. Yeah.
Thank you very much. So we have a few minutes. We can take a few questions if you want. We have a question down there. Do you want to take this? We can switch with the mics. Hopefully we'll be okay.
Hello. Thank you for the presentation. It's a generic question. I understand this is a private blockchain thing, right?
Yeah.
And in the first part, you mentioned the need for a trusted central authority for the certificate authority. Is that?
Yeah, you need authority of certification. Yeah.
So if you already have a central authority that you need to trust, why do you need a distributed ledger?
Because you are not talking about the same thing. The certificate authority just gives you the keys to sign your transaction, nothing more. It doesn't interrupt you in any exchange in the system or interaction with your application. That's the way that you see the certificate authority, is the one that is delivering keys. So you have everywhere in the world, that LDAP or whatever, everyone has a system that has certificate authority.
Okay, let me rephrase the question then. Do you think that, are you aware of any research towards getting rid of authorities, central authorities, because the need for certification authorities troubling in many applications of blockchain. For example, IPFS, I don't know if you're aware of it, it's an attempt to have a distributed HTTP protocol based on blockchains, and the problem of requiring a central authority is what keeps it from being more mainstream. So are you aware of any work towards getting rid of the trusted authority?
Well, if you don't really want to use one, it means that you don't want any censorship in your blockchain. You have to use the public version. But you will have other problems, because you cannot use the kind of consensus, for example, PBFT, you cannot use it in the public blockchain. You have to use proof of work or proof of stake. They are quite heavy in resource. You cannot do whatever you want. And you have another problem is legally, you are dealing with someone that you don't know.
By the way, just to note that IPFS is not based on a blockchain and it doesn't have a central authority. It's peer-to-peer. I'll talk to you about it outside, yeah. Any other questions?
There,
right.
One there.
One more.
Hi. You said that your contracts, the contracts through the fabric, are upgradable. Does it helps to, because on the Ethereum, you are just publishing your contracts without the upgradability. Does it help to have a better trust after the upgrades? I mean, if I deploy the contract, it works. After that, I'm upgrading it to something else, and it maybe does something different from the first version. How can I monitor this thing as a user of the system?
Well, you have to see that when you are deploying the source, it's public source. That when you're deploying smart contract, you can actually go on the block and see what is deployed. And then you have hash of the code itself. So when you're deploying new version, you can see what has been deployed. So you have to check and be careful, of course, about what has been deployed and by who. Secondly, there are some Endorsements Policies. Some people, they can deploy one smart contract, and some other users, they can interact or not. And this is part of the signature. When you deploy your smart contract, at this time, you define the policies for which user can do what with your application. So you have this kind of control. And of course, if you don't really trust what has been deployed, just look on the block and say, okay, I don't want to use anymore your application because you have upgraded, you have changed one part of the code that does not satisfy me. But what you have to understand, here you are in a consortium, in a private blockchain, so everyone in the blockchain is an active, how can I say, user, is a member. So you should check everything, and everyone has to be working for the good, you know? If someone is cheating on the blockchain, the consortium will try to revoke his access or ask him to leave because he's not following the rules of the consortium. But this is not possible in a public blockchain because everyone is invited. So do you check what is a smart contract that has been deployed? More or less never. Who has deployed it? You don't even know sometimes. So it's very different.
Right,
so just a question, how many of you are checking open source code? I mean, are reading the code in open source project? How many of you?
You're lying.
Yeah? Very few. And there are some ways to be careful with that. Signing now, most of the time now, they ask you to sign in, for example, NPM, or when you're deploying a jar on Maven, a repository, or this kind of thing. Now you need to sign, and because you need to know who has modified what at which moment, and you need to do like a difference to see what has been changed, because you trust these packages, but you never look inside. Maybe there are some backdoors on everything. Maybe there are quite a lot. So it's the same problem with the blockchain. When you're deploying, you need to access the code source and to check yourself, and to know who has signed and at which date and what he has done.